Questions from yesterday. Isaac, what?
Can you do 20?
Yeah, one what?
1, 3.
1, 3, question 20.
Yeah.
Um, yeah, this is kind of a pain, right?
Yeah.
So, personally, if you, I would always suggest that you plot it out because it might be easier to actually plot it, and then you won't have to use the distance formula. And part of the reason I'm saying that is because I'm noticing there's a 3 for the y value, right? And maybe it is. All right. I think personally plotting things out is easier because I can count quicker than I can do the x minus x. All right. But I'm not saying that's what you have to do.
I tried that.
So here's what you have to do. Watch. You have to go here. Then you have to like double click and then add a page.
Oh,
Yes. And then it automatically adds it to here. It just put it here. So then you just scroll it down to the bottom. And actually, though, that might not be a bad thing since we're doing, right, since we're doing it for this particular problem right here, adding a page underneath is probably a good idea. Then you put the graph paper in there. All right. Well, we haven't done it yet. All right. We're getting ready to do it right now. All right. So, again, I would think graphing it would be okay. All right. And then, in the interest of time, I need you to tell me. You go back on your page and tell me what the coordinates are. What are the coordinates?
There are -1, 3.
-1, 3.
3, 3.
3, 3.
5, -1. And -2.
-2, -1.
Mm-hmm.
All right. So this right here is kind of a pain, but I'm glad we're doing it because hopefully you understand what I mean about it's easier, in my opinion. It's easier if I just draw it out. Do I agree? Because then this right here is just 1, 2, 3. The top is 4. Right? And the bottom is what? The bottom is 7, right? Now, hopefully you can do this. This is the square root of 17. Come on now. This is what I was trying to tell you yesterday. All right? What I want you to do is I want you to make a right triangle out of it, and look how much easier it is. Right? This length right here is 4. This is 1. So that has to be the square root of 17. Does everybody see that? I just think, come on guys, from here, let me do this. From this point right here to this point right here, that's 4. Yes or no?
Yeah.
And from here to here is 1. So what's wrong with the square root of 17? A squared plus b squared equals c squared. 4 squared plus 1 squared today is the square root of 17. Everybody good with that? And then over here, the same principle. This right here is still what? 4, but this is what? 2, so you should be able to quickly say that's the square root of 20. But of course, we're not leaving it as the square root of 20. We're leaving it as 2 radical 5. So then my perimeter is 11 plus the square root of 17 plus 2 radical 5. You agree with that now? All right, there's 3 or 4 questions, I'm sure. So, go. Let's stay on this page right here, 1-3. Does anybody else have any questions on 1-3? Anybody have any questions with 1-3? No. Yeah, look, I'm just saying, look, just in the interest of time, I don't want to keep going back and forth, right? I'm saying, does anybody have any question with this page right here? Nothing, right? Okay, now we're going down to the next one. All right, and now we'll talk about this. Number 3. Caroline traces out the spiral shown in the figure. The spiral begins at the origin. What is the shortest distance between Caroline's starting point and her... Am I confused? I mean, aren't we just going from here to here, right?
Okay.
That's all we're doing, right? Didn't ask me how many steps are there all the way around.
No.
Just says, what's the shortest distance? The shortest distance between 2 points is a line, right? So if I'm looking at this, again, I'm trying to emphasize to you, in my opinion, I would just make the right triangle. This right here is what? 2, 1, 2, 3, 4, 5. So that is the square root of 29. Nice if you know that. Anybody have any questions with that? Go ahead. All right, let's see what number 4 says. This must be harder, right? All right, so let's see what it says. It says the United States Capitol is located 800 meters south and 2,300 meters to the east of the White House. If the locations were placed on a coordinate grid, the White House would be at the origin. What is this between the Capitol? I think it's just a squared plus b squared equals c squared. What? 800 squared plus 2,300 squared equals square root.
Square root of 5,900,000.
Is that right? So we know, if you want, now this is what I tried to show you a little bit last year, but this year I'm going to help you out, or I'm going to review this. All right, so please look up. First of all, does everybody understand that it's 800 squared plus 23 squared is equal to that distance squared? Do you agree with that? Right. That's exactly what I was just going to talk about. So because you're smart, you're going to say it's 8 times 100 plus 23 times 100, right? So your answer is going to be 100 times the square root of 8 squared plus 23 squared. All right? Listen to what I just said. All right? That will eliminate a lot of the what? The extra zeros, the extra headache of trying to break something down. All right? They're called triples. All right? Now, what's 8 squared plus 23 squared? 593. All right? Yes.
Why? How did you? Okay, so it was everything is squared, right? The 800 to 100 second the distance. And then I get that 8 times 100 equals that, but did you equals distance squared, right?
Right.
And that's just not written. Okay. And then
Plus. Come on, what? You good now? All right. Anybody else? All right. That's a good review of the square roots. If you have a multiple, you can pull that multiple out. All right. Yes.
okay, so when it have the word problems, like on number 1 and number how do you get the middle? I just don't know which one to use.
How do I get the what?
The middle, like the midpoint.
Midpoint. Remember what I told you? The midpoint is the average. The average of the x's and the average of the y's.
And that one you divided
By 2. Right, so it's x plus x divided by 2, or x sub 1 plus x sub 2 divided by 2, and y sub 1. All right, now let's move to the next one. I thought this was relatively easy, right? This worksheet, kind of easy, basic. information. Does anybody need to do anything on that?
17, are they like equal to each other?
Uh,
Or is EBD equal to DBC?
EBD is congruent to DBC,
Yeah.
right? So you just set them equal to each other. What?
I kind of did what you did with 18, where I found x and then I did 22, and then I actually plugged x in to it, and then I got 40. Okay, is
And
that,
40 plus 40 is 8.
so,
We're looking for the large angle.
yeah, and then, okay, so it's 80, but then you just,
I wrote EBC equals 80.
yeah, so why did you, okay, but I was talking about 17, but it's 40, but then you should have just plugged, what I'm saying, that you just plugged in your x.
Yes, that would be the answer. Right? Okay, here we go. Now, the angle relationships. All right. Now, I'm not real sure how much you remember. All right, so let's talk about obtuse just means greater than 90. And vertical angles, they're across from each other, right? So vertical angles occur here. Let me blow this up just to remind you. When you make an X, right, and if I number this just for right now, 1, 2, 3, 4, which ones are vertical? 2 and 4, 1 and 3, yes. Now, the adjacents are the ones that are next to each other. So adjacent would be 1 and 2, 2 and 3, 3 and 4, 1 and 4, right? Everybody good with that? All right, so good. So if we talked about 1, 5, 2 obtuse vertical angles. 2 obtuse vertical angles. Yes, go. Ava. BC what? Wait a minute. Just let me. She said BCG and what? DCF. Perfect. That is correct. All right. Those are obviously greater than 90 and they're vertical angles. All right. There are more, right? You could say BFE and GFH. Right? BFE and GFH. Let me see something here. Linear pair. Let's talk about linear pair. All right. Linear pair. Pair means 2, right? And linear means what? A line. So let's define linear pair. Linear pair, well, you would say this is a line. Those form a linear pair. Right? The reason they form a linear pair is because they're adjacent, right? They're adjacent to each other, and they form a line. Now, what's true about a linear pair? What's true about angle 1 and angle 2? They're supplementary. What else? What does supplementary mean? They add up to 180 degrees. Complementary makes 90. I don't know what you mean. Oh, now we're going back to the actual question. Name a linear pair whose vertex is B. So I'm going to find B right here. Now, somebody name the linear pair. Go ahead, Ava. No. The reason why, because you need 2 angles. Tell her. Yes. A, B, C, and CBG. Right? So he did A, B, C, and then we did G, B, C. Those would be linear pairs. Right? Now, for a linear pair, remember, they have to share a common ray. For a linear pair, they have to share a common ray. Is everybody good with that? Name an angle not adjacent to but complementary to FGC. All right, so let's break this down. So I need to find FGC, so I'm going to highlight FGC. FGC is right here. So what's that angle measure right there?
40.
That's 40, so I'm going to go ahead and put a 40. Now angle FGH is complementary, right? But it's adjacent. So what angle are we referring to here? BCG. No, I don't think so. What is it, Ryan?
FGA.
F? No, that's incorrect. Incorrect. Oh, what do you think, Hayden? CD. No, guys. CD is automatically already 90. What? What is it? D. Yes, of course, it's DEF. Because DEF is how many degrees? 50. So 50 plus 40 is what? 90. That means that they're complementary, but they're not what? They're not adjacent. All right. All right. Number 4. Name an angle adjacent and supplementary to DCB. So let's take a look at our figure. Let's try to find DCB, which is right here, DCB. So, Trey, go. BCG, that is correct. You could also say what? DCF or DCH, either one. All right, I don't think that's hard, guys. All right, number 5. 2 angles are complementary. The measure of one angle is 21 more than twice the measure of the other angle. Yeah, for some reason this was hard last year for some of the kids because they're lazy. All right. How many angles are we referring to? 2. So if you want, here's my opinion. Here's the first and here's the second angle. Do I have any idea what the first angle is? No, it's X. There is a relationship between the 2 angles, which is 2x plus 21, right? The second is 2x plus 21. Now because they're what? Now look up here, guys. 3x plus 21 equals 90. Now this year I'm trying to show you a little bit more with math, so look up. It sounds kind of dumb, but here's how my mind looks at that. Look up because it's not traditional way. Did I see that? Yeah, why did I do that? Because to me, I think it's easier. I think it's easier. Right? You can divide by 3 first if you divide everything by 3. And you would only do that if all the numbers were what? Divisible by 3. You wouldn't do that if it was, 82. All right? I just think that's an easier way to look at that. All right? Yeah, so now they say, what are the angles? Right? So the first angle is 23. Now, would I do 2 times 23 plus 21? Nope. I would just do 90 minus 23. Right? What is it?
67.
Good. Subtract 20 first, and then subtract 3. That's easier. 90 minus 20, 70. 70 minus 3, 67. All right? Now, if you're afraid you made a mistake, you could do what? Plug it in and see if you get 67 when you plug 23 in for x. All right. So basically 6 is what? The same thing, so we can move on. All right. Now, what does this figure right here mean?
Perpendicular.
Perpendicular, right? So perpendicular means 2 segments or 2 lines that intersect to form a what? A right angle. Thank you. Right? Two lines that intersect to form a right angle, and a right angle measures how many degrees? 90 degrees. Anybody have any questions with that? All right. So if FGE, thank you. if I have FGE is 90, so it would just be what? What would the equation be?
5x plus 10 equals 90.
5x plus 10 equals 90. All right? And if you want to, divide by 5. I would definitely say that's x plus 2 equals 18. X equals what? 16. Okay. I think I'm happy with 8. You can do... Everybody knows what complementary means, right? Add up to what? 90. Linear pair. What? Somebody give me a good definition of linear pair. Do you think you got it? We say share array. It's not a technical, right? So I'm just, so if two angles are adjacent, they share array. All right? But then what's the other key component to linear pair? Nope, has nothing to do with the vertex. They're supplementary. You with me on that, right? So adjacent angles are linear pair, two adjacent angles that are supplementary. All right? We already talked about vertical angles. I'm pretty good with that. I feel good about the street map. So let's move on. All right? Now, 1-6. A few little things here. All right? First of all, we talk about concave and convex. We'll start with that. All right? Now, I'm going to give you the formal definition here, and then I'll tell you how I remember it. All right? This right here is concave. The reason the first one is, yes, that would not be the formal definition, but that's how we talk about it.
Use the word concave.
Right. The formal definition is this. If you draw the diagonals, and a diagonal is on the outside of the shape, it's considered concave. Everybody with me on that? But we also just say forms a cave, right? So it's concave.
So
All right.
number one's concave.
Number 1 is concave. Number 2 is considered convex, because when I'm drawing the diagonals here, every single diagonal that I try to draw is on the interior of the shape. You with me on this? All right, so that's the difference now between concave and convex. All right, now you have to know the difference between regular and irregular. Does anybody remember that? What's regular?
Regular is like all the lines have
Okay,
they're all similar. Like,
it's not similar.
it's an equilateral triangle.
It's like
What is it?
on a mirror.
What's true about all the sides?
They're the same.
They're congruent. All sides are congruent. And then, special case, what else has to be congruent as well as the sides?
Angles.
The angles. So you are considered regular. You are considered regular if all the sides are congruent and all the angles formed are also what? Congruent. So now they're trying to show you something, for example, well, they don't have a good picture here, but if all sides are congruent, are all angles congruent?
No.
And the answer would be no. Think of a square that would be considered regular. Then we would talk about a rhombus, which is a tilted square, right? Are the angles the same if you tilt the square? No. All right, but the sides are the same. So the sides can be congruent without being regular. Is everybody with me? Your sides can be congruent without your angles being congruent. Is everybody with me on that? All right, and technically, your angles can be congruent without your what? Sides being congruent as well. Yes. No. The reason it can't be regular is because, think about it this way. At some point, it's going to swing. It makes a different angle. All right? So we would say for number 2, that is what? Irregular, right? I'm sorry. I said 1. All right? 1 is definitely irregular, but 2 is what?
Regular.
Thank you. And 3 is definitely Irregular. All right? And it is, you're right, convex. It's convex. Go.
The hardest part of this is identifying by the
Go.
number of sides.
Is it possible for it to be concave and
Concave.
Courtney
No.
just asked that.
All right. It's not. Now, if you want to name each polygon by the number of sides, I didn't read that. How many sides do we have here? 6. So if there are 6 sides, it's called a what? Hexagon, right? How many sides on number 2?
9.
Now, to me, it's easier to count the vertices than it is to count the sides. So it's a nonagon. Very good. And number 3, quadrilateral. All right, very good. Quadrilateral because it has 4 sides. All right, now I'm not gonna. You can. I'm just gonna review the formulas here. All right. So perimeter of a rectangle is twice the length plus the width. That's how I'd like you to remember it instead of 2L plus 2W. It's easier, in my opinion, to work with it if you know it's twice the length plus the width. Of course, area is what? Length times width, right? It says here leave your answer to the nearest tenth, but we're not going to do that, right? Especially for a circle, we're going to leave it in terms of pi, right? So the perimeter is called what? If a circle, circumference, right? So your formula was 2 pi r, or what?
Pi d.
Pi d. Your area was what? Pi r squared. Remember, does everybody hear what I mean? So you're leaving your answer in terms of pi, right? So your area for that circle would just be what? 49 pi miles squared, right? I don't want you to type in pi on your calculator. Anybody have any questions with that? Leave the answer in terms of pi, just like you leave it in simplified radical form. All right. So they're trying to fool you here. The left side is what measure? 8.1. So the area of a triangle is half the base times height, right? So I'm just letting you, if you forgot, you can write that down. Go back and do the multiplication. Use your calculator to find the answer in a minute. Is everybody good with that? Yeah, and do the, well, I'm assuming, right, add those up. Well, the perimeter of a triangle is just, what do you want me to put, A plus B plus C down?
Yeah.
I didn't see that separate.
All right. Alrighty. No, we wouldn't do that. All right. Now, add graph paper, right? Draw it out, and then find the perimeter and area. I'm pretty confident about that. All right, now what I want to do is I want to get to number 9 because this is on the SAT quite a bit. All right, and again, I need to show you this technique, and I want you to be good at this technique. So I want everybody to look at number 9. It says, suppose the length and width of a rectangle are doubled. What effect would it have on the perimeter? Justify your answer. Can anybody tell me? If you double the length and width, what's it going to do to the perimeter? Quadruple. Very smart. Now you're going to prove it. All right, you're going to prove it. So here's the proof. Please pay attention. It's really easy if you learn this. But most kids, for whatever reason, never learn this. All right? So what's the formula for perimeter? Good. 2 times the length plus the width. Does everybody agree with that? So that would be the original, right? Now, the new perimeter, if I double the length and width, would be 2L plus 2W. Is everybody hearing me? Right? Everybody good with that? Now, look carefully. All right? I doubled both. So now I want to simplify it. B is equal to what? Or I'm sorry, P is equal to 4L plus 4W. Do you agree? And down here, the original would have been what? 2L plus 2W, right? So did it really multiply by 4? Is it 4 times bigger? It's only what? It's only 2 times bigger. It's not quadruple. Double. All right, it's double. So everybody see that, right? Now again, I'm just trying to show you that, right? You modified the length and the width. Look what I'm telling you. You modified the length and the width. What did you do to the length? You doubled it. What did you do to the width? You doubled it. You replace L with what? 2L. And then you see what happens. Now, let's do the same thing here. Let's talk about the area, though. Oh, is that the next question?
Yeah.
All right. So now you'll see what I mean for the next question. All right. The area is what?
Quadruple.
Right. The area is length times width, right? So now what do we do to the length and width? We do what? Double both of them. So your new area would be 2L plus 2W, which is equal to what? 4LW. Please make sure you understand what I'm saying. I'm taking the SAT book and putting all of them on the test. All right? So you're going to have questions very similar to this. All right? It's very important. So what happened to the area? It quadrupled. All right, it quadrupled. All right? One of the questions I saw was if you double the length and half the width. You double the length and half the width, what happens to the area?
It's the same thing.
Stays the same. That's not hard, right? It's not hard because you replace L with 2L and half W, multiply it together, they cancel out, right? But things a little can get tricky if you don't know to substitute in the new variable, all right? So we're going to definitely have a couple questions done with that. And that's just circumference and area, I believe. All right? So I think that should be it for me today. Tomorrow what's going to happen is I'm going to call you up to my desk, and you're going to show me all of this. All right? And that'll be all your grades. All right? Anybody have any questions? All right, so that's good for me today. I know we have like 15 minutes, probably something, maybe even a little bit more. Get it done right now. Get it done right now. As a matter of fact, I might call you to my desk just to see what you've done and give you your grade since I have a little extra time. I don't want to waste anything. Is everybody good? All right.